All right, we might as well begin. Welcome back to another video on our Breadboard to Market series. If you're liking what you're seeing, enjoying the channel, please like and subscribe. Hit that bell notification on YouTube to be notified of any new videos when we post them, when we upload them. So the last video, we pretty much finalized the PCB layout, got all our traces laid down, connected all of our air wires. We added a few additional circuits, such as a debug interface. We made sure that was there. We threw in like a status LED, and we threw in a temperature sensor close to the stepper motor driver chip to help serve as a guide for the active cooling that we're throwing in here. So now we're going to kind of go through, review, make sure we don't need, make any changes, make adjustments, update our design rules. So the DRC tries to, we try to get a zero error design rule check. It's going to really be limited to the different options we can set in the DRC checks. Mainly spacing between traces and pads, and hole sizes, things like that, text sizes. So we'll see about all that, see about fixing all that. So the first thing we'll want to do is just kind of verify if our parts placements and layouts are kind of good where we want them to be. This test point here for the ground, basically to kind of tie in these guys, we can kind of go ahead and move this over here. Let's see here, it's 39 up. No, let's uncheck that. Go to footprints. 39 and 82.5 should put us in the right spot. Probably no 83. All right. So I'll do that. B to refill all our copper pores, basically. Yeah. So now we'll also kind of go through our texts. So we'll want to make sure that all the designator texts kind of flow with the normal convention, left to right, bottom to top, and that everything's pretty much within the same, and has the same font settings. So I don't know if this is a graphical issue or 27. Yeah. So we okay. So it looks like a lot of the text here, something happened. So I think there was a way we can go through and edit all the text at the same time. I don't remember where that was. We'll see if we can find it. Tools. I think it was under graphics. No, not graphics. It's not graphics. Text and graphics properties. So screen, scope reference designators, set to specified value, line thickness, 27, 635. Okay, so that fixed all the designators. Now, they all match as far as size and height, font thickness and everything. So let's kind of just give it a good glance to make sure the top layer follows the conventions. and we're not overlapping or under a part anywhere. It'll be clearly visible. So let's go to here. That way everything's on the top. 23, 24, IC6 is outside. Okay. Kind of just going through. Right now we're just looking at designated text. We'll deal with labels and stuff later. Kind of look, make sure things kind of look nice, neat. As clean and organized as possible. Bottom silk screen, let's hide the top. So the bottom silk screen will be similar, bottom to top, but it's mirrored, so it's going to come from the way it's going to look. It's going to be looking from left to right. So just keep that in mind when you're looking at the bottom text. It'll look correctly. When it's printed in, you can actually have the visible board and see it there. All right. That looks good there. Go and view that again. All right. So now let's kind of look at our labels. What we can do is we can go to the 3D viewer and kind of get an idea how things look. If we think the font size and, the strength of it basically looks okay for what we're trying to accomplish. All right, boot enable. We'll fix kind of alignment. I mean, we might be able to make these fonts a little bit bigger. Let's go here, 1 millimeter. 7. Yeah, you know what? Let's see if we can edit those. Text and graphic properly. Reference session together. Layer, scope, PCB text items. Maybe that's what they are. Yeah. Font text width. Oh, wait a minute. 1.27. 0.127. See if this works. Yes, it did. Okay, I left the designators alone. So it's a little bit bigger, and I think that'll work. Shouldn't be too crowded out. All right, position. All right. Mm, 15.5 should be good. Okay. Oh. Oops. Let's make sure we're there. There we go. Okay, that'll work. And clean it all out. 15.5. Oops. That look okay. Should be able to pop that one up. All right, look at that. All right, what did I do there? 48. All right, let's go. Yeah. Go, kind of clean this up. 74 point, wait, no, 48.5. All right. Okay. I could kind of go over a little bit. That'll work. Just kind of cleaning things up. Making things look just a little neater. Because this is a product that, you know, other people will see, not just for me. So I want it to look as presentable as possible. Even though this is the first iteration, and there's probably going to be six. Oop, that went all over the place. Other iterations, we may have to, you know, clean up the design, fix a few things. Right now, though, I want it to look as nice as possible. Okay, so we got this VA here. Let's go ahead. All right. There we go. That should be fine. 106 in. All right, 1.25. 6. There we go. 106. That looks good. All right. All right. Okay. Take another gander at it, see what it looks like. Readable. Everything makes sense. Nothing's too outlandish. Nothing's too far gone. Okay. Okay, we got that guy up there. All right, everything looks good there. I'm happy with it right now. We'll get a better feel when we actually get boards in hand, but I'm pretty sure that's going to look okay. Sometimes just visual representation without actually having the board in hand is just, it's just difficult. So one of the things we want to also accomplish is to be able to run the design rule check, run the DRC, and try to get as close to 0 errors as possible. So a lot of these are, let's see where that, stop. Okay. Okay, so it's giving a clearance error here. But we're getting clearance errors everywhere with all these pads. So we're going to delete all markers. So let's see if we can find our design rules. Tools and I can run that. We're going to look at our design rules. I think they're in the board setup. All right, physical static up. I'm not terribly worried about that because we're not going to use the Gerber files to define the stack up. We're going to basically all that's going to be, I mean, it's going to be defined based off of everything, but the rest of the stack up, like thicknesses and everything, that's just going to be through the board house. Graphics. Okay, constraints. Minimum clearance. See, so here's the problem, or minimal clearance, because it doesn't look like we can do a minimal pad to pad clearance. So it's not ignoring footprints. It would be nice to tell it to ignore footprints. So let's see if we get, by just changing that, how many errors? Hole clearance. Oh, see, it's upset about this hole clearance right here. Nothing we can do about it. That's actually part of the footprint. There's a basically a staking hole. Not really a staking hole, more like an index hole. There's two of them in the USB connector. One here and one here. There's nothing we can do about that. Yeah, there's nothing we can do about that. That has nothing to do with us. Okay, let's see. All right. Now that, try working through this. Just hide that, hide that, hide that. Yep, nothing we can do about that right now. Trying to work through these. Unconnected. Well, yeah, it's unconnected. Did we not? Yeah, they're not connected here. So I don't know why. I mean, they should, yeah, I don't know why it's giving an error. Unconnected, that's fine. Yeah, and we're getting clearance violations. Net class default clearance 0.203. Delete all markers, close the site. Why didn't it should have saved it? Oh. All right, yeah, I don't know why it didn't save that. Probably have to learn custom rules, how to add those. Yeah, let's see, syntax help. Let's see, rules. Clearance. Edge clearance, length, hole clearance. Looks like we're gonna have to, we'd have to, huh. We can even do max V account, that's kind of cool. Yeah, would have to learn how to custom write rules in here. That's going to take some time. So let's just kind of stick with what we easily can work with. Well, clearance should be, yeah. I don't know why it's upset because we have, okay, copper to hole clearance. Yeah, that's that. We may just have to. Mm, yeah, this is unconnected items. Okay. No, that should be connected. I thought I tied all that in. All right. Let's fix that real quick. All right. Let's fix that. Good thing that caught that. I want to make sure there's no of these connection issues. All right. Tie that to ground. Solid. All right. Grab these big ground BS. You in right there. Fill in. Yep. There we go. All right. So caught that. All right. Nothing looks too far out of whack there. On the DRC. All right, so we finally got that down. There's no ignored. All right. Okay, connected. So these are all right. That class default actual 0.2. Yeah, there's really not much we can do about that. Non-plated through a hole. That's fine. I mean, that's an error we'll have to accept. Clearance. Non-plated through a hole. We have to just accept those. Clearance. Clearance. Yeah, it's just they're too close together. We might, yeah, unconnected. Yeah, clearance. All right. So that one. It'd be nice if there was where I could just highlight and say it's okay, like accept it. Just gotta go through each one of these, make sure it's nothing critical. Because this is really nothing we can do anything about. It's the footprint. And I changed the setup, so I don't know why it's still complaining about that. I'll have to look more into it. But for the sake of what we're trying to accomplish here, okay. Yep, it just doesn't like the clearance. The gap between these pads are just too close together. It'd be nice if KiCad can be told to ignore footprints, to ignore pads inside footprints and stuff. Because I built plenty of these boards and the clearance is fine. There's not actually a problem there. Yeah, I just want to make sure nothing here is like a showstopper. make sure anything unconnected is actually okay, because unconnected, yeah, it's unconnected. And the clearance, again, there's nothing we can do about it. The clearance between this footprint here and the pad here, that's the part. There's nothing we can do about it. Okay. Clearance violation. Now, again, I wish we could just tell it to ignore pads in a footprint. I have a feeling this is going to be the majority of the errors we're finding, but we've got to go through them and make sure that it's not a short anywhere or a stub violation. Until the day comes that we can, I might be able to edit custom rules, but again, like I said, I'd have to learn that, and that's way beyond the scope of what we're trying to accomplish today. But unfortunately, that's what the review process is, though. You want to look through, make sure everything you've done looks correct. Take the time. This is the best, the easiest, and the cheapest point in a project to find errors and correct them. We haven't bought parts yet. We haven't paid for boards yet. So this is the cheapest point in this project to find and fix errors. You don't want to order boards and realize, oh, you've got some major problems. Things you could have caught and fixed. Yeah. I just want to make sure that we don't have stray material, a stray line shorting things out, a piece of trace that we forgot to delete or move around, or something accidentally dragged isn't going to short anything out. Wow, this is really between these two, and then between that one and ground. I mean, that's why we've got all these violations here. Okay, we don't have to click on both those. I see what it's doing. Okay. Yeah, I changed it. Okay, 0.1750. Yep. This poor pick is nothing but a violation. Or not pick. This is the UART chip, and I've used this UART chip plenty of times before in other projects, so I know the footprint's fine. All right. Okay, let's see. Again, that pad and that pad, there's nothing we can do about it. Make sure, yep, that pad and that pad. Because the copper pour is obeying the rules we set. So it's nice and clear. That's not the problem. Now we're on the stepper driver. Let's see. Yep, between those two pads. Oh, here we go, the stepper driver. Wow, here we go. I know, the really boring fun stuff, isn't it? But it's all part of the job. This is what you have to do in order to, this is important work. Somebody has to do it. Now, if you can grow a company to where you can basically have like an engineering tech or another engineer actually handle the review process, go through and double check, that would actually be ideal. But if you're a one-man show or the only engineer on your team that does this work, like at Sanctuary Software, I'm the only engineer that does electrical work, that does board design and layout. So I have to go through all these processes and double check all my own work. Technically, that shouldn't be. You should always have a second set of eyes, but sometimes it's just unavoidable. So you do the best you can to catch errors before they become a problem. And mistakes happen. I've ordered boards before with mistakes in them, and, it just happens. Courtyards overlap. Okay. I had a feeling that would be one of the errors. I don't care about courtyards overlapping. That's fine. So, especially for these parts, these little guys right here, there's more than enough distance. The actual part is physically about that large in diameter. So, it's a test point. I don't care. So, the courtyard helps define typically your minimum distance between components when you're laying out a board. You tend to want to not overlap your courtyards. Now, but that also depends on the density that you're going for. So if you're going for an HDI board, so a high density interface, basically, where, your parts are crammed together. Sometimes you could set up multiple courtyard rules to allow certain overlap. It really depends. On some parts, you can, like capacitors, resistors, things like that. You're pretty much almost button them up right against each other, leaving just pretty much enough space in between so you don't get solder bridges and stuff. So it really depends. So the courtyard is a good helper to understand, how you're laying out to make sure you're not like encroaching on another component space. But unfortunately, it's not always the best tool. And I knew courtyards were going to overlap. But with these parts, I don't care with those test points. Hole size out of range. Min hole. Okay, minimum hole, so 254. Let's make sure that is actually within our specs, because if I did something wrong. So that is, okay. Yeah, 254 is our minimum hole. So that means a design rule is just out of whack. Now, we're going to try to fix... I'm not going to re-review all that. Let's see here. Minimum hole. Let's see here. $254. So that's a micro via. We're not really working with them. Okay. Minimum text height. Text thickness. All right, there, that way. Save that. Let's see what kind of DRC. So you're at like 199 or something up there. 111. All right. We really dropped those down. So whole clearance. We've already passed through all them. Let's get down to the courtyards, because we know those are still here. I never cleaned up any rules for them. That'll be kind of like our marker. Courtyards overlap. All right. Let's get through them. All right. Wow. Thermal relief connection on zone. Incomplete connection. All right, let's see what in the world we've got. So we might have a pad 17. Okay, incomplete. Okay, so let's get in here, fix this zone. So I bet you we got a zone set up wrong. Thermal reliefs, solid. Okay, we're gonna hit re-pour. All right. And then we're going to rerun the check. Run DRC. We knew that was at the bottom. We got rid of an error. All right, now we've got the courtyards overlapping. Now let's see if we can kind of get it to 0. Let's see here. Clearance violation. Okay. And let's just see. So we're okay with the courtyards overlapping. We have no other errors other than in these test points. That's fine. So let's see here if there's something in here for courtyards, which I don't see anything for courtyards, so I might not have to care about them. But here, minimum clearance is 0.2, which is fine. Hold clearance. Coppered edge, we want to keep that because that's the any copper like pad, annular ring on the via, anything plated through hole, anything. We want it to be at least half a millimeter away from the edge, called pullback. And then here in a minute, I'll give you 0.2. Let's see here. Let's see. $110. Yeah. Clearance default. Clearance violation. I don't know why 0.203, which we should have already had here. Let's make sure maybe I'm not. Phoenix, yeah, that's fine. Solder. No expansion. Okay, so we've selected here, so it will automatically tent the vias, which are fine. Defaults. Make sure nothing here is out of whack. Yeah. Well, oh, net classes. Oh. 0.2. Okay. Okay, I bet you that'll fix that error. Markers, run DRC. 46, okay. Let's see if we can further clean up. Okay, that's fine. Custom rules. I mean, that's fine. Teardrops. So teardrops are actually good to add. Let's see if we can add teardrops. So what teardrops are, see if we can add them first. What if we can edit teardrops? Track. Let's see here. Filter. Oh, add teardrops with specified values. Scope, plated through holes, SMT, and so let's see. Okay. Repour anything. Okay. So teardrop. Basically, it bolsters your connection to a pad or a via. I mean, other than the big zone pour like this, but if you notice, so we've had our traces, and now instead of just going in here, we've got this. It's called a teardrop. So that just kind of bolsters the connection between the trace and the component, and the pad or the via. They're always good to have. But let's see if any of them violate the rules. So we have 46 right now. Okay, we're going to rerun it. Make sure that it didn't create new violations. Nope, 46. Yeah, I wish we can get rid of the courtyard overlap. Should be in here somewhere. It's obviously something that should be like a checkbox or something. So yeah. All right, all right. So right here's all the defaults for teardrops. The defaults are usually okay. Tuning for differential pairs and stuff. Embedded files. Not worried about that. Okay. We'll stack up. Yeah. Make sure we're not missing it. It'd be nice to be able to just get rid of that error for the courtyards. But it's fine. Yeah. You know, it. You don't want to. I don't want to bury myself into any of this. So we got the teardrops. Yeah. So let's go ahead and get rid of, delete all those markers. Okay. So now we've done the DRC. We've cleaned up the errors. We've made sure there's no unconnected. We tied in everything that was supposed to be connected. Everything looks beautiful. Our copper pores are poured and filled in. We're looking beautiful. Our text everything was looking good. Another quick glance at the board to make sure we're acceptable there. So something we'll work on. So we're going to pretend we've already done it. So when we're down waiting for parts to come in and kind of catching up on QMS and other things, which kind of reminds me, this is something else I forgot to do. So yeah, this is how bad I am. I like designing too much. So we've already basically captured schematics. We're still kind of doing that. We technically captured the PCB layout. We already did that. Yeah, so I'm really bad at this. Really bad at this. Really horrible. And I'll admit that. It's things, habits to get into. But we've already captured. We've already done that. We've created that. Let's do an in process. Review. We're going to do PCB. Let's see, menu. We have manufacturing file generation. All right. All right. So we kind of did the PCB layout review. All right. So, yeah, that's going to be kind of in process. We're going to put that in the backlog because we really haven't started that. We'll take care of that next. So, manufacturing files. We're going to generate the bombs. So, these are kind of in process we're going to be working on. So, we need to spit that out. But one of the things I want to get to real quick before I get too far ahead of myself. I don't know why my computer likes doing this and not showing icons down there, but I'm not going to cry and complain about it too busy, too important, other things going on. So we're pretty much there. So one of the things that I'll be generating during our QMS catch up, well, like I said, we're waiting on parts so I can, get videos made while we get things caught up in between. Things that technically we should have been doing prior all along. That's me. That's my bad. Again, I'm really bad for this because I enjoy designing and building more than anything. Paperwork's, honestly, documentation is just it's a necessity, and I get that, I understand it, but you throw a project in front of me to work on it, I'm going to work on it. That's how bad I am. Again, that's why most companies have like engineering techs, QMS, quality experts, basically staff employees that can take care of that type of technical stuff to allow their engineers or, to actually do the job of designing and building products, designing the boards and laying them out. Large companies have even separating those tasks out even further to have the engineer that designs the product via the schematics. They capture the schematics, figure out all the parts, and then that's passed off to a PCB layout technician. So the larger the company or more complex the products, sometimes it'll get passed off to a PCB layout technician who will take over the reins and do this part of the job, the layout. They would be more specialized in understanding all the rules, more of the ins and outs, all the calculations, all the math involved for impedance control. But unfortunately, I don't have that luxury. I have to do everything myself, which I don't mind. It's a experience that I like doing. It's fun, but it's just something to keep in mind. When you're doing this on your own, you've got to do everything. And it's easy to get scatterbrained. It really is, especially when you love doing this part of it, but don't like doing paperwork. And I get that. I completely get that. But the paperwork's important. That's why we're going to catch up on it. But one of the things I'm going to do is I'm going to use LibreOffice Calc and create some templates. So I'm going to be continue to use VS Code and, markdown files for like ISO documentation, things like that. But I'm thinking that I'm not really too happy with trying to do CSV files and all that in VS Code. And I want to be able to have, basically Excel files, things like that. So I'm going to make like checklists. So we're going to do like a PCB layout checklist where, when you go through, you want to make sure, you meet these criteria. It's going to be a checklist that's based off of the design standards that we've drafted, that we started drafting here, and we'll formalize into a more document. It'll be basically a checklist for the specific project. It'll be a QMS artifact that will be proof that you followed this process, and then you checked off that you did it, and it'll be stored in the project folder. So there'll be so in the stepper folder, we're going to have like basically project documents, and that's where we're going to store all the results from testing. Maybe test logs. We'll have that stuff in there. We'll have maybe design logs, things like that. We'll have it all in there, and we'll create a structure and add that to other documentation down the road, so that for each subsequent project, you follow the same process. That's basically what it's all about. We might even change some of these from Markdown files to Excel files or LibreOffice files, just because they're easier to work with. The traceability matrix I might even pull from a CSV and just turn it into a regular spreadsheet type file. Again, I like using VS Code. For one thing, it's free, and Markdown files are easy to understand, and it handles all these different things. But sometimes just, using something like this where you can visualize it easier is a lot better. And then also for like the project management. And then we'll cover more stuff in depth in the other videos I plan on creating. So I don't want to shortchange anybody here who's actually really interested in this. with my bad habits. I don't want to shortchange the importance of doing this stuff. I don't want to overshadow that. So, but we'll do that in other videos. Like I said, we're going to be waiting on parts for at least a week, week and a half. So we'll have time to all play around with that. So we've gotten this. So there's a couple of things that we need to do. One is generate the manufacturing files. So let's just say, so we've gone through the review process. We've done the DRC. We've checked everything. We've verified everything. We're happy with where the company logo is. We're happy with the tax, all the designators, everything looks right. We're happy. Let's just say it checks all the boxes. So now what we need to do is figure out how to export a few things. One are the fabrication outputs. Perfect. So the important things to really, okay, so this will do bill of materials and everything. All right, cool. So the Gerber files, export Gerber. All right. So I'm gonna have to figure out KiCads. Okay, all right. So I have an output directory. So let's see, I'm closing that. So let's see if we can go to the project, hardware, separate control. Now, you know what, let's see, let's create a new folder in here. And actually create a project outputs folder. Project, and then version, which is 01, project outputs. So then what we're going to go then is fabrication outputs, Gerbers. We're going to select project outputs. Perfect. All right. Do you want to use path? Yes. So let's go ahead and use that. All right. Let's see if that works. So these are the layers we want to use. Top copper, interplane, bottom copper. Don't need adhesive. We need the top paste and bottom paste. So that's what's going to determine your stencil and the opening. Basically, that's mainly for your solder stencil. We'll show you more of that. I'll show you more of that layer. Your top mask, your bottom mask. You don't need drawings, content, edge cuts. I think that is, yeah, that's the board outline. We don't need the margin. We don't need courtyard. We don't need these. Now we can do fab. So if we close this, so what we can do, there's also fab nodes. So let's just assume that's fab. All right. Let's front fab. No, let's not. Let's assume user 1. All right. Can I rename that? Rename, no. So I guess that's just whatever you want. So what we can do is on user 1, all right, so what I've got, if you really want, and we'll do this. All right, so let's see here. So we'll do this on user 1. We'll call that our fab notes. Let's do a text box. Kind of do it over here. Now, again, we're going to clean all this up and we'll make better documentation on the road. Now, we'll have to fix all this. So, now you could Google this information. That's where I got a lot of this. Are basically PCB fabrication nodes. And these are helpful because they can travel with the Gerber files. Now, a lot of the newer ways of doing things, you don't, a lot of times you don't really need to put the fab notes in the PCB, Gerber files anymore. It's helpful, but not really required anymore. A lot of times manufacturing vendors and stuff are more than okay with separate files, like say a PCB fabrication document, which we'll get into more detail later in other videos maybe. When I start using Circuit Studio, separate documentation, we can create like a packet, but it's just as easy to throw it into a fabrication notes. So, so here's, your IPC class for manufacturing. We want to go for class 2. So for anybody who doesn't understand the IPC classes, I'll just cover that really briefly. So there are technically 3 classes. There's class 1, 2, and 3. So class 1 is really reserved for, to just use an easy to understand phrase, just your garbage electronics. This is the kind of stuff you find at an end cap in your grocery store with a battery that lights up and makes noise, or, does something silly, like a cheap throwaway kid's toy. Yeah, it has like a little coin cell in there. It's like a little magic wand that lights up. It's got candy with it, and you're just gonna throw it away at the end of the day. That's technically class 1. Very low standards on that. That is basically that type of electronics. My opinion is I'm tired of disposable electronics. I really am. I think it's really disgusting. I think as a society we need to change, but that's just me. That just disposable electronics are dumb. It's a dumb concept. We're wasting valuable resources just throwing it in the trash. But that's just my opinion. You can have whatever opinion you want. So class 2 then covers pretty much every other electronics in our daily lives. This is our televisions, our smartphones, our computers, our keyboards, our headsets. Pretty much everything else that's built using electronics. Would be considered class 2. This is your everyday. This is the stuff in your car, your automotive class. And then there's class 3. Class 3 is medical, military, aerospace. That's the level for class 3. And each class basically has a set of requirements to follow to make sure that it adheres to that standard. That's beyond, going deeper than that is beyond the standard of the scope of right now. But, class 2 is generally an electronic device you're going to design. But if you're doing medical, aerospace, military, class 3 is what you're shooting for. And that's a whole different animal. And you're just going to be bearing yourself on a whole bunch of new responsibilities that you may not be prepared for. Because then you're also looking at possibly being required to be AS9100, which is basically ISO 9001 with a whole additional stack of requirements on top of it specific to the aerospace industry. A lot of times you're not going to get any type of aerospace type work unless you are AS9100 certified. I've been through the certification process for that at one of my last companies. I was part of the team that actually got us AS9100 certified. It's basically, like I said, it's ISO 9001 with just a ton of other stuff on top of it, specific to the aerospace. So again, you could, if I'm not mistaken, there's also an automotive standard if you're really looking to make automotive components that you may be required to jump into and become certified. So really think about what you really want to do before planning. So then this is just, basic other requirements you want them to follow by. Surface finish. So Hazel, lead free, hot air solder leveling, lead free, or we could do lead free Hazel, solder mask, LPI, liquid photo, imageable. In a nutshell, it's basically just a very fancy way of saying it. It's a inkjet printer that spits out UV curable ink. The solder mask. I'm thinking that. Basically the same process. So we're going to just do green. Silk screen. Okay. White non-conductive epoxy. Blah, blah, blah. 4 mils and 4 mils. I don't like working in mils. I prefer working in... So I'm just going to kind of go over here because my brain doesn't calculate very well. Millimeters. Minimum conductor width. Oh yeah, we're way above 4 mils. So what we can do is and just change that to millimeter. And a spacing of, I think it's 0.200 I think 203 is what we set for the traces. We want to make sure our traces were. All views are tinted to both sides, unless, yeah. We could change that to unless solder mask open and grow, but that's fine. Should be full non-conductive. All vias on pad. So that would be, okay, let's see if I can kind of move that. So vias that are like on this ground pad underneath this, well, no, not that guy. This guy right here. So the motor driver. So the ground vias I threw on there on that exposed pad. So what it's saying is they should be filled with non-conductive epoxy and surface should be flat. It's a via and pad process. Yeah, solder mask 1:1. We don't want them bigger than they need to be. RoHS compliant, lead-free materials. Manufacturers. We don't have to keep that, but they usually do put that, and it's fine. Okay, our tolerance. Let's change that to millimeters. Plus minus 0.0254 millimeter. All dimensions are in millimeters unless otherwise special. Flatness requirements. Basically, you don't want the board to have any twists in it. Greater than. Test in accordance with the standard PCB. Okay, that's fine. Temperature grade 150 Celsius or equivalent. Okay. Equipment material shall be halogen free. Layer to layer plus or minus 2 mil. Let's get that converted over. Minus 0.0508 millimeter. My etching tolerance, etching requirements document. Let's go ahead and what we can do for lines that we don't need, we can just NA, and that way we can reserve them for down the use. So what I can do is I can try to copy this text file. I'll get this copy of this text file and throw it in with the project resources. So yeah, this is just like impedance. Yeah, we're not doing any matched. So these are going to be a lot of general manufacturing. That actually came out pretty good. Let's see. Okay, that moves it. So we'll kind of move it over there. Kind of embiggen that. Something else we can do. Yeah, we can embiggen that. That's fine. All right. Is we can also use user 2 because there's no dimensions. If we really wanted to, so let's see, we can use user 2. It's fine. Let's see if we can throw in a dimensions. No dimensions here. Oh, is this it? Nope, not page settings. Oh, is there? Let's see if there's a. Oh, here we go. Scroll through again. Okay. Ah, all right. Dimensions. Double click that. Okay. User 2, some millimeters. I know we could suppress trailing zeros, but I kind of like having them. All right. Oh, perfect, perfect, perfect. So it's good to have dimensions. For one thing, when we actually go to order the board, we might be able to set that as a standard. And then keep aligned. What if I can rotate that? 0? Yeah, all right. We can go bigger fonts if we have to. So we have, dimensions of our board. Now, if we really want to, we can... Oh. All right. Okay, so... All right, let's see now what we can do then. Is if we want to... Sometimes it's helpful to know that information. Can it actually say millimeters? Well, that's fine. All right. Always move that if we need to. Okay, that works. And there's another good reason for this. So if you want to design an enclosure, you've got a quick reference to all your dimensions right here. Okay, so let's just grab another critical, because then we can use this one as kind of like origin 0. See if we can do this. Grab this. All right. Oh, we want it from here. Oh. I don't like that. Oh. Let's suppress that. Okay. Leave that. So we got the holes. Okay. Overall board size. It's good to have those, throw them in there. Just some extra documentation never hurts. Sometimes there's no such thing as being overly documented. So we're going to save that. So we got notes in there. We're okay with that. Sometimes the board house will, send you emails and questions, but this is pretty much general. And we'll deal with things as it comes. But let's at least get our Gerbers. So we want our copper layers, our paste, our edge cuts, and then user 1 and 2. Now, this is the thing to pay attention to. Plot on all layers. You do not want to do that. Just leave this alone. Just ignore that. Leave that alone. Okay. Do not place on fabrication layers. We'll just pull that out. Check zones before plotting. Generate. Let's see. Use protile phonemes. Yeah. No longer recommended. I'm going to tell you right now, it's kind of bull crap. Yes, we're going to use the protile file names. Gerber Jowl Fob. Okay, that's fine. Net loose attributes. disable aperture macros. Yep. Okay. 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 We're going to go on plot. So then if we go here to our project output, it didn't save it. Oh, you little booger. So it, yes. Now it should plot. Oh, so I have to go through and delete. Okay, so I'm going to go through and delete the files. All right, let me. All right. And Gerber, G1, GTO. GM1. Bottom layer. There we go. Hopefully that cleans that up enough. I can just go through it. Yeah, looks like that's it. All right, all right. So that's what we wanted for that. We're going to close that. Fabrication outputs, draw files. Okay, good. It saved it there. Absolute. Excellent. That should be fine. Generate. Okay, okay. We're going to generate. That's the roll files. Close. So that should be all the drill file DRLs. Okay. Yeah. So bottom layer, bottom solder mask, bottom paste mask, bottom overlay, GM1. That is basically general mechanical layer 1. Top layer, top solder, top paste, top overlay. These are internal plane layers, plane layer 1, 2, you know, not necessarily plane or signal, they're just internal layer 1, 2, 3, and 4. That's fine as long as everything's right. That's the Gerber job file, your drill files, and then our 2 user files for the fab notes and the dimensions. So that's that. Now, depending on who your board house is, and you'll learn this as you do this and you get set on vendors that you want to use. So there's a couple other files you may need. You may need ODB files. And it's just basically it's a different. You can use the ODB++ files to manufacture off of. It's basically like the Gerber files, but in a totally different format. You may need the IBC netlist file. It really depends. Component placement, that would probably be your pick and place. Let's see what that does. Output directory. Let's make sure it gets put into project outputs. Select folder. All right, units ASCII. So that you want to be a CSV file. Use drill place file origin. So what that should be, it should be using, so it should be, everything should be referenced off of this little red square. So it's your XY pick and place file. Basically, we're creating the pick and place file. So we can generate a single file with both front and back positions. Let's go and do that. We don't need to worry about negative X coordinates. Exclude with do not populate. Exclude all footprints with through hole pads. Nope. Okay. Include only SMD footprints. Yes. So we only want, basically, we don't need the pick and place file for hand place parts. Now, some parts you can, like through hole parts, can be pick and place with a machine. There are machines that can do it, but we only care about SMD footprints. So we're going to generate the position files. Close, and now in here there should be a CSV file. That is your pick and place file. So we can even go here, right click, rename, separate controller, Just rename it Pick and Place. A board manufacturing. So if you have SMT equipment, pick and place machines, you can use this file, allow them to import in to actually start doing your board layouts and stuff. Or a manufacturing facility can use that to import into their pick and place software to help figure out what parts go where, and then they can just make adjustments by hand. So that, as far as our fabrication outputs, that should be all we need. Bill of materials. Let's see what this does. Bill of materials. So it's going to want to throw out a CSV file. We'll work with that later. So we're going to throw in the project outputs. But we want to kind of give it a name so it's easy. So we're just going to call it BOM initial. Or we're going to call it a generated BOM. So, because we're going to go through it and we're going to clean it up. And did I not place it in the right spot? Oh, there it is. Generated BOM. Okay. So, we've got our Gerber files and our generated BOM. So, I'm going to go and end the video here because we're dragging in a little over an hour. And I don't want to, take too much more time. So in our next video, we will actually do an official Gerber file review and start working the BOM file, clean it up, and hopefully start throwing, create the BOMs, the bill of materials in Odo to start tracking and maybe even start getting parts ordered. Got a small little leg of stuff to go before we can order anything, but hopefully we can get it done. Mainly some reviews, our BOM reviews, throw everything in Odo, get all that, maybe even manufacturing orders created. Basically just help keep track of our inventory, what we're pulling in, what we're spending, maybe, and update the budget basically when we actually do order parts to show consumption. But we'll do definitely the Gerber file review in the next video. I thank you for watching and checking us out, and have a good rest of your day, and we should be able to stream tomorrow, do another video Monday around 6 p.m. Have a good one.